There's a blind spot beneath our solar system, a place we almost never look. And right now, something the size of a small moon is rising through it. While telescopes track the famous interstellar visitor, 3I Atlas, a far larger object has been quietly approaching from below. It's called C-2014 UN-271, 150 kilometers wide, dark as coal, and at a distance where it should be completely frozen, completely dead, it just started violently outgassing. Scientists can't fully explain why. Is this just a comet waking up early? Or is something else happening out there? Something we're only beginning to detect? Stay with me, because what comes next might change everything. If you're as captivated by these mysteries as I am, go ahead and hit that like button and subscribe so you won't miss what happens next as this story develops. Now, let's dive in. While astronomers around the world train their telescopes on a fast-moving interstellar visitor called 3I Atlas, something far larger has been quietly stirring in the darkness below us. I'm not talking about beneath the Earth. I'm talking about beneath the entire solar system itself. Its name is C-2014 UN-271, but most scientists just call it Bernardinelli Bernstein, or BB for short. This object is not some ordinary chunk of ice and rock tumbling through space. BB is roughly 140 kilometers across. That's about 85 miles, roughly the distance between two major cities. To put that in perspective, most comets we get excited about are maybe a few kilometers wide. This thing could swallow dozens of them whole and still have room for dessert. What makes BB even stranger is where it's coming from. Most objects in our solar system orbit the sun in roughly the same flat disk, the ecliptic plane, like vinyl records stacked on a turntable. But BB, it's coming in at an inclination of roughly 95 degrees. That means its orbit is nearly perpendicular to everything else. Imagine all the planets lined up on a dinner table, spinning clockwise, and then imagine a massive cannonball shooting up from underneath the table at a right angle. That's BB. It's approaching from what amounts to a cosmic blind spot, a region we rarely monitor because, well, nothing's supposed to be down there. Now here's where things get interesting. And by interesting, I mean deeply unsettling. At a distance of roughly 16.6 astronomical units from the Sun, that's about 16 times farther from the Sun than Earth is, the Atacama Large Millimeter Array, ALMA for short, detected something unexpected. Carbon monoxide outgassing from BB. Carbon monoxide, actively venting into space. At that distance, the sunlight reaching BB is roughly 1/275th the intensity we get here on Earth. It should be frozen solid, inert, dead, and yet it's awake. Comets typically don't start showing activity until they get much closer to the Sun, usually inside the orbit of Jupiter. But BB is already active way out there, far beyond the traditional snow line, where we'd expect this kind of behavior. So the question scientists are now asking themselves, often in quiet moments when they think nobody's listening, is this: why is it active so early? What's waking it up? You might be thinking, okay, it's just a really big comet doing comet things. Fair enough, but consider the timing. Right now, as we speak in late 2025, we're witnessing not just BB's awakening, but also the arrival of 3I Atlas, an interstellar visitor with its own set of bizarre properties. We're seeing black holes flare to unimaginable brightness. We're discovering new moons around Uranus that we somehow missed for centuries. The cosmos, it seems, is getting louder, more active, less predictable. What if BB isn't just a comet? What if this massive, ancient worldlet, this relic from the birth of our solar system, is responding to something bigger? What if its awakening is the first visible symptom of a larger energetic shift rippling through the sun's domain? Something we're only beginning to detect? I know what you're thinking. That sounds like the setup for a disaster movie. And maybe it is. But it's also real. BB is real. The outgassing is real. The geometry is real. And the fact that nobody can fully explain why it's behaving this way at this distance is very, very real. Over the next several parts, we're going to dig into what we know about BB, its size, its orbit, and why that orbit matters more than you might think. Then we'll explore the theories, some mainstream, some decidedly not, about what this object might represent. We'll talk about black swan risks, the kind of low probability, high impact events that keep mission planners awake at night. We'll wade into the esoteric and conspiratorial corners of the internet, where people are asking whether BB is some kind of harbinger. And finally, we'll zoom out and look at the bigger cosmic picture, including 3I Atlas and other recent anomalies that might, just might, be connected. By the end, you'll have a choice to make. You can file this away as a fascinating but ultimately mundane astronomical curiosity, a big comet doing slightly weird comet things. Or you can let yourself wonder, just a little, whether we're watching something far more significant unfold. Whether the solar system, after billions of years of relative stability, is entering a new phase. A phase where the giants wake up. So let's start with the basics. What exactly is BB? Where did it come from? And why should you care about a giant ice ball that's still years away from even reaching its closest point to the sun? Because if the data is right, and if the models hold, this thing is already changing, already moving, already awake. And it's coming from a direction we never thought to watch. Let's talk numbers. BB's nucleus, the solid core of this cosmic monster, is estimated to be about 140 kilometers in diameter. Some measurements put it closer to 150 kilometers. For context, that's roughly the size of a small moon. In fact, it's not much smaller than some of the minor moons orbiting Saturn or Uranus. If you placed BB next to Comet Hale-Bopp, one of the most famous comets of the late 20th century, Hale-Bopp would look like a marble next to a bowling ball. And Hale-Bopp was already considered enormous for a comet. But size isn't the only oddity here. BB is dark. Very dark. Its surface has an extremely low albedo, meaning it reflects very little sunlight. Scientists describe it as darker than coal, darker than asphalt. This isn't just a cosmetic detail. A dark surface absorbs more solar radiation, which means that even at great distances from the sun, BB could be heating up more efficiently than a brighter object would. That absorbed heat could be driving sublimation of ices beneath the surface, turning solid material directly into gas, which then escapes and creates the outgassing we're seeing. The ALMA detection I mentioned earlier is worth unpacking. ALMA observed BB using millimeter wave radio telescopes and detected the J equals 2-1 rotational transition line of carbon monoxide at 230 gigahertz. In plain English, that means they caught CO molecules spinning and emitting a specific wavelength of light that only carbon monoxide produces. They also detected a dust continuum, which means there's not just gas escaping, but also tiny particles being dragged along with it. This is the signature of an active comet. Except, again, BB was 16.6 AU from the sun when this happened. At that distance, traditional comet models predict almost no activity. The sunlight is just too weak. And yet, there it is, puffing away like a chimney in winter. Now let's talk about the orbit, because this is where things get cinematically strange. BB's perihelion, its closest approach to the sun, will occur in January of 2031. At perihelion, it will be roughly 10.95 astronomical units from the sun. That's just outside the orbit of Saturn. So even at its closest, BB never gets anywhere near Earth. You can sleep soundly, knowing this thing isn't going to crash into us. But that's not the point. The point is the geometry. BB's orbit is inclined at roughly 95 degrees to the ecliptic. That's almost exactly perpendicular. Most comets, most asteroids, most everything in the solar system orbits in roughly the same plane, give or take a few degrees. But BB is doing something completely different. It's coming up from below, slicing through the solar system at a right angle to the planetary disk. This is what astronomers call a retrograde orbit, or in some classifications, a near-polar orbit. Either way, it's weird. Why does this matter? Because the solar system isn't empty space. It's filled with the solar wind, streams of charged particles flowing outward from the sun. It's laced with magnetic field lines that spiral outward in a structure called the Parker spiral, and it's organized around something called the heliospheric current sheet, a wavy, rippling boundary where the magnetic polarity of the solar wind flips from north to south. Most objects in the solar system spend their entire lives moving roughly parallel to this current sheet, gently bobbing up and down through it, like a boat on a calm ocean. But BB is going to punch through that current sheet almost perpendicularly, like a knife cutting through a layer cake. What happens when a massive, outgassing object crosses strong magnetic boundaries at steep angles? Honestly, we don't know. There are theories. Some scientists think it could trigger enhanced outgassing as magnetic fields interact with charged particles in the coma, the cloud of gas and dust surrounding the nucleus. Others think it might cause jet activity, focused streams of gas shooting out from specific points on the surface. Still others think nothing unusual will happen at all, that BB will just sail through like any other comet, geometry be damned. But here's the thing. BB will cross the ecliptic plane in August of 2033. That's the moment when it passes directly through the orbital disk where all the planets live. And at that moment, it will be interacting with solar wind structures, magnetic fields, and particle streams in ways that no other observed comet has, simply because no other observed comet of this size has ever had this kind of orbit. Then, there's the matter of mass and gravity. At 140 kilometers across, BB isn't just a loose pile of rubble held together by weak ice bonds. It has real self-gravity. Enough to hold itself together as a coherent object. Enough that when gas escapes from the surface, it doesn't just fly off into space. Some of it might fall back down, forming a temporary atmosphere or a dense, lingering coma. This creates feedback loops. Gas escapes, some falls back, heats up the surface, causes more gas to escape. It's a process that smaller comets don't really experience because they don't have enough gravity to recapture their own material. Scientists have run models trying to predict what BB's activity will look like as it approaches perihelion. Some models suggest a steady, predictable increase in brightness and outgassing. Others suggest the possibility of outbursts, sudden, dramatic increases in activity that could make BB visible to the naked eye. And a few models, the ones that keep mission planners up at night, suggest the possibility of fragmentation. That's when a comet breaks apart, either due to rotational stress, thermal stress, or outgassing pressure. If BB fragments even partially, it would become a very different kind of object. Multiple pieces, each potentially active, each with its own trajectory, each harder to track. So now we have the foundation, a massive, dark, self-gravitating worldlet on a near-perpendicular orbit, actively outgassing far from the sun, approaching a perihelion that will take it through regions of space where magnetic and particle interactions could amplify its behavior in unpredictable ways. It's not just a comet. It's a natural experiment in cometary physics, orbital mechanics, and solar system dynamics all rolled into one. And the clock is ticking. Perihelion is 2031. The ecliptic crossing is 2033. We have less than a decade to figure out what BB is, what it's doing, and what it might do next. Which brings us to the next question. What if this isn't just physics? What if there's something deeper going on? Here's a thought experiment. Imagine you took a piece of the solar system from 4.6 billion years ago, from the very moment when planets were still forming, and the sun was a temperamental toddler throwing tantrums of radiation, and you froze it. Just locked it in a cosmic freezer, untouched, unchanged, perfectly preserved. That's essentially what BB might be. A time capsule, a relic, a fossil from the dawn of everything we know. The Oort cloud, where BB likely originated, is a vast, spherical shell of icy bodies surrounding the solar system at distances ranging from thousands to hundreds of thousands of astronomical units. These objects formed in the early solar system, closer to the sun, but were kicked outward by gravitational interactions with the giant planets, Jupiter, Neptune, Uranus, Saturn. Out there in the cold and dark, they've been sitting ever since. Barely changed, barely warmed, just waiting. BB was one of them. Until something, a passing star, a gravitational nudge from a distant encounter, sent it falling back toward the sun. Because BB has spent most of its life so far from the sun, it likely retained ices that other comets lost long ago. We're talking about ultra-volatile materials, carbon monoxide, carbon dioxide, nitrogen, methane, ammonia. These substances evaporate at very low temperatures, which means they're among the first things to boil away when a comet approaches the sun. Most comets we study are depleted in these materials because they've made multiple trips through the inner solar system, losing a little more with each pass. But BB? This might be its first journey inward in billions of years, its first real exposure to sunlight in eons, and that means its chemical composition could be pristine. The ALMA detection of carbon monoxide is a strong hint that BB is rich in these primordial volatiles. Carbon monoxide is one of the most volatile ices we know of. It sublimates at around 68 Kelvin, that's minus 205 Celsius. At BB's current distance, temperatures are probably hovering somewhere in that range, maybe a bit warmer on the sunlit side. So the fact that CO is actively venting suggests there's a lot of it beneath the surface, just waiting to escape. Now let's think about what happens when an object this big starts outgassing. With smaller comets, gas and dust escape relatively easily. The comet's gravity is weak, so particles just fly off into space, forming the characteristic tail we all recognize. But BB is different. Its gravity, while still far weaker than Earth's, is strong enough to hold on to some of the material it ejects. This creates what some researchers call a supercoma, a thick, dense shell of gas and dust that lingers around the nucleus instead of streaming away. This supercoma can change how we see the object. It scatters sunlight, making BB appear brighter than it would otherwise. It can also create optical illusions, making the nucleus seem larger or more diffuse than it actually is. But there's a darker side to this process. If gas is escaping from beneath the surface, but then partially trapped by gravity, you can get pressure buildups. Imagine a kettle on a stove with a lid that's almost, but not quite, sealed. Pressure builds. Heat builds. And then, suddenly, the lid blows off. In cometary terms, this could manifest as an outburst, a sudden, violent release of gas and dust that dramatically increases the object's brightness and activity. Outbursts are common in comets, but in an object as large as BB, an outburst could be spectacular and unpredictable. So what's triggering the activity in the first place? That's the million-dollar question. At 16.6 AU, sunlight alone shouldn't be enough to drive significant sublimation. The energy input is just too low. So scientists have proposed alternative mechanisms. One possibility is internal heat. Radioactive decay of elements like aluminum-26 or potassium-40 could generate warmth from within, slowly heating the interior over millions of years. But for an object that's been frozen for so long, it's unclear whether there's enough radioactive material left to make a difference. Another possibility is crystallization of amorphous ice. When water ice forms rapidly in very cold conditions, it can be amorphous, meaning its molecular structure is disordered. Over time, this amorphous ice can transition to crystalline ice, a process that releases heat. If BB's interior contains large amounts of amorphous ice, this crystallization could provide enough energy to drive sublimation of more volatile materials like CO. It's a slow process, but on geological timescales, it adds up. Then there are external factors. Cosmic rays, high-energy particles from outside the solar system, constantly bombard objects in space. When they strike ice, they deposit energy, which can cause localized heating and sublimation. At great distances from the sun, where solar heating is negligible, cosmic rays might be the primary driver of activity. Some models suggest that BB's outgassing could be powered almost entirely by cosmic ray bombardment, at least until it gets closer to the sun and solar heating takes over. There's also the magnetic field question. As BB moves through the solar system, it's traveling through the sun's magnetic field, which extends far beyond the planets. This field isn't uniform. It's structured, dynamic, with current sheets, shocks, and turbulent regions. When a massive, conducting object like BB, whose coma contains charged particles, moves through these magnetic structures, it can experience forces and heating effects that smaller, less active objects wouldn't. Some researchers have speculated that magnetic reconnection events, where field lines snap and release energy, could occur in BB's coma, depositing heat directly into the gas and dust. All of this raises a fundamental question. Is BB just waking up because it's finally getting close enough to the sun for its ices to respond? Or is something else going on? Is the heliospheric environment itself changing, becoming more energetic, more active, in ways we don't fully understand? Could BB's awakening be less about BB and more about the space it's moving through? That's a question we'll circle back to. But for now, let's acknowledge the possibility that this isn't a simple comet doing simple comet things. This is a primordial giant, a frozen world from the birth of the solar system, stirring from a sleep that's lasted billions of years. And the fact that it's doing so now, in our lifetimes, at a moment when other strange things are happening in the cosmos, is either a coincidence or a clue. The data hasn't decided yet, and neither should we. Let's talk about things going wrong. Not wrong in the sense of BB crashing into Earth. That's not going to happen. Wrong in the sense of BB behaving in ways that defy our models, our predictions, our understanding of how large comets are supposed to act. In risk analysis, there's a term for events like this: black swans. Rare, unexpected, high-impact occurrences that nobody saw coming because the models didn't account for them. And when it comes to BB, the black swans are circling. Start with non-gravitational forces. When a comet outgasses, it's not just releasing gas into space. It's also creating thrust, like a tiny rocket engine. Gas molecules escaping from the surface carry momentum, and by Newton's third law, that means the comet itself experiences a reaction force in the opposite direction. For small comets, this effect is well documented. It can change the comet's rotation, its spin axis, even its trajectory over time. But for an object as large as BB, the calculations get complicated. How much thrust can a 140-kilometer worldlet generate? How does that thrust get distributed across the surface? And what happens if the outgassing isn't uniform? If BB develops active regions, spots on its surface where outgassing is concentrated, those regions will act like directional thrusters. Over weeks, months, years, they could torque the object, changing its spin. They could accelerate it along its orbit, causing it to arrive at perihelion slightly earlier or later than predicted. They could even nudge its trajectory enough to shift its closest approach distance by thousands or tens of thousands of kilometers. That might not sound like much, but in orbital mechanics, small changes compound. And if we're planning any kind of spacecraft mission to BB, which some scientists have proposed, getting the trajectory wrong could mean missing it entirely. Then there's the outburst scenario. Comets are known for sudden increases in brightness and activity, sometimes brightening by several magnitudes in a matter of hours or days. These outbursts are thought to be caused by the exposure of fresh, volatile rich material, either from landslides, cave-ins, or the blow-off of an insulating dust layer. For BB, an outburst could be dramatic. Picture a section of the surface, maybe several kilometers across, suddenly venting gas at high velocity. The coma brightens. The dust production spikes. Observers on Earth see a dramatic change in BB's appearance, maybe even with the naked eye. But there's also a darker possibility. What if an outburst is violent enough to fracture the nucleus? Fragmentation is the nightmare scenario. Comets do break apart. We've seen it happen. Comet Shoemaker-Levy 9 famously split into more than 20 fragments before slamming into Jupiter in 1994. Comet 73P/Schwarzmann-Wachmann 3 broke into dozens of pieces in the early 2000s. When a comet fragments, its surface area increases dramatically, which accelerates sublimation and makes the fragments even more active. For BB, fragmentation would transform it from a single, trackable object into a swarm of smaller bodies, each with its own trajectory, each potentially hazardous to any spacecraft trying to study it, each adding complexity to an already complex situation. What could cause BB to fragment? Several things. Rotational stress is one. If BB is spinning and that spin rate increases due to outgassing, the centrifugal force could eventually overcome the object's structural strength, pulling it apart at the equator. Thermal stress is another. Uneven heating from the sun could create temperature gradients that cause the surface to crack and buckle. And then there's outgassing pressure itself. If gas is building up beneath the surface faster than it can escape, The pressure could literally blow chunks of the nucleus off into space. Observationally, scientists are watching for warning signs, changes in BB's brightness that don't match predicted models, asymmetries in the coma that suggest localized jets or active regions, non-gravitational accelerations that show up as deviations from its predicted orbit. All of these would indicate that BB is not behaving like a simple, inert rock falling toward the sun. They would suggest something more dynamic, more energetic, more unpredictable. Now, from a mission planning perspective, all of this matters enormously. Several groups have proposed sending a spacecraft to BB. The idea is compelling. Intercept it somewhere around perihelion, study it up close, maybe even land a probe on its surface, collect samples of primordial material that's been frozen since the dawn of the solar system. It would be one of the most scientifically valuable missions ever flown, but it's also risky. Launch windows are tight. If BB's trajectory changes due to non-gravitational forces, the mission could fail before it even arrives. And if BB fragments, navigating through a debris field becomes exponentially harder. There's also the question of what we do with the data. If BB does something unexpected, something that doesn't fit existing Comet models, we need to understand why. Is it because BB is fundamentally different from other comets? Or is it because the environment it's moving through, the heliosphere, the magnetic field, the solar wind, is different from what we thought? Either answer has implications. The first tells us about the diversity of solar system bodies. The second tells us about changes in the solar system itself. And then there's the public perception angle. If BB has a major outburst and suddenly becomes visible to the naked eye, people are going to notice. They're going to ask questions. They're going to want answers. And if those answers involve uncertainty, if scientists have to say, "We're not entirely sure why this is happening," that opens the door to speculation. Some of it will be scientifically grounded. Some of it will be less so. And some of it, as we'll discuss shortly, will veer into the realm of the esoteric and conspiratorial. So here's where we are. We have a massive, ancient, outgassing worldlet on a strange orbit, approaching a perihelion where its behavior could become highly nonlinear. We have credible scenarios for outbursts, fragmentation, and trajectory changes that could make BB a much more dynamic object than anyone expected. And we have a limited window of time to study it before it swings back out into the outer solar system and disappears for another few million years. The stakes are high, the risks are real, and the clock, as always, is ticking. But before we start planning missions and modeling trajectories, we need to address the elephant in the room, or rather, the worldlet in the outer solar system. Because for every scientist carefully analyzing BB's spectral lines and orbital elements, there's someone else asking a very different question. What if this isn't random? What if BB's awakening means something? Let's step outside the laboratory for a moment. Let's leave behind the spectroscopy and the orbital mechanics and the careful, measured language of peer-reviewed papers. Let's talk about what people are saying in other corners of the internet, in forums and chat rooms and YouTube comments, where the conversation about BB takes on a very different tone. To some, BB is not just a comet. It's a symbol, an omen, a harbinger. The fact that it's approaching from beneath the solar system, from a direction we rarely look, fits a certain archetypal narrative, the return of the repressed, the shadow rising, the hidden thing coming to light. In mythology, gods and monsters often emerge from the underworld, from beneath the earth, from the dark places we prefer to forget. And now, here comes BB, a giant worldlet from the cosmic underworld, the Oort cloud, stirring from a billion-year sleep and moving toward the sun. The timing, too, feels significant to some. BB's awakening coincides with the arrival of 3I Atlas, an interstellar visitor with its own set of anomalies. It coincides with increased solar activity as the sun approaches solar maximum in its 11-year cycle. It coincides with discoveries of new moons, black hole flares, dark matter revelations. To a certain mindset, these are not coincidences. They're synchronicities, meaningful patterns in the chaos, signs that something larger is shifting. What could that shift be? Some propose that the solar system is entering a new region of the galaxy, a zone with higher cosmic ray flux, stronger magnetic fields, or different interstellar medium density. This, they argue, could be triggering increased activity in distant objects like BB. The heliosphere, the bubble of solar wind that surrounds the solar system, is constantly interacting with the interstellar medium. If that medium changes, the heliosphere changes. And if the heliosphere changes, objects within it, especially large, sensitive objects like BB, might respond. Others take it further. They suggest that BB is not just responding to external stimuli, but is itself a kind of energetic antenna, a massive reservoir of primordial material that's now releasing energy into the solar system. They point to ancient texts, mythologies, prophecies that speak of cosmic cycles, of epochs ending and beginning, of celestial events marking transitions. BB, in this view, is the physical manifestation of a metaphysical shift, a signal that we're moving from one cosmic age to another. Now, before we dismiss this entirely, let's be clear about something. The overwhelming majority of scientists who study BB see it as a natural object behaving according to known physical laws. There's no credible evidence that BB is anything other than a very large comet. The outgassing is consistent with sublimation of volatiles. The orbit is consistent with Oort cloud dynamics. The timing is consistent with random perturbations that occasionally send these objects sunward. Coincidences happen. The universe is vast, and rare events occur all the time, simply because there are so many opportunities for them to occur. But science also teaches us to be humble, to acknowledge that our models are approximations, that our understanding is incomplete, that the universe is under no obligation to behave the way we expect. And while the conspiratorial and esoteric interpretations of BB may lack empirical support, they raise questions worth considering. What if there are large-scale energetic phenomena we don't yet understand? What if the solar system's environment is more dynamic, more responsive than we've assumed? What if objects like BB are sensitive indicators of changes we haven't yet learned to measure? There's also the question of what BB represents philosophically. For most of human history, we believed the heavens were static, unchanging, eternal. Then we discovered that stars evolve and die, that galaxies collide, that the universe itself is expanding. We learned that change, not stasis, is the cosmic norm. But we still tend to think of our own solar system as stable, predictable, safe. BB challenges that. Here's an object that's been invisible, unknown, irrelevant for all of human history. And now, suddenly, it's active. It's here. It's doing things. It reminds us that even in our own cosmic backyard, there are giants we don't know about, processes we don't understand, events we can't predict. Some take this further and ask, if BB is waking up now, could other objects be waking up too? The Oort cloud contains trillions of icy bodies. What if BB is just the first one we've noticed? What if there's a whole cohort of giant worldlets, all beginning to stir, all beginning to respond to some subtle shift in the solar environment? It's a speculative idea, but not an impossible one. And if true, it would suggest that the solar system is entering a more active phase, a period of increased cometary flux, more impacts, more close encounters, more opportunities for discovery, and, yes, more risks. Then there's the fringe idea that BB might not be entirely natural. I want to be very careful here, because this is where the conversation often goes off the rails. Some people have speculated that very large, very unusual objects in space could be artificially constructed, or at least artificially modified. This idea gained traction with Oumuamua, the first confirmed interstellar object, which had an elongated shape and showed non-gravitational acceleration that some argued couldn't be explained by outgassing alone. Subsequent analysis suggested that outgassing could in fact explain Oumuamua's behavior, and the scientific consensus is that it was a natural object. But the speculation persists. For BB, there's no credible basis for an artificial origin hypothesis. Its composition, as far as we can tell, is consistent with natural ices and rock. Its behavior is consistent with cometary physics. Its orbit is consistent with Oort cloud dynamics. But the fact that people even ask the question reveals something important. We want the universe to surprise us. We want to discover that we're not alone, that there are intelligences out there, that the cosmos is more than just rocks, and gas, and radiation. And large, unusual objects like BB become screens onto which we project those hopes and fears. So where does that leave us? With a spectrum of interpretations, ranging from the strictly scientific to the wildly speculative. The scientists see a fascinating but natural phenomenon. The esotericists see a cosmic signal. The conspiratorially minded see a cover-up or a hidden truth. And most people, honestly, don't know what to think. They see the images. They read the headlines, and they wonder, is this something I should be paying attention to? Is this something that matters? The answer, I think, depends on what you mean by matters. Will BB directly affect your daily life? Almost certainly not. It's not going to crash into Earth. It's not going to block out the sun. It's not going to trigger earthquakes or storms or any of the apocalyptic scenarios that occasionally circulate online. But will it tell us something important about the solar system, about how it formed, about how it's changing? Absolutely. And that matters. Because the more we understand about the cosmos, the better equipped we are to live in it, to navigate it, to maybe, someday, explore it beyond our own little planet. With that said, it's time to zoom out. To look at BB not in isolation, but as part of a larger pattern. Because BB is not the only unusual object capturing our attention right now. There's another visitor, another anomaly, another puzzle. And its name is 3I Atlas. While BB has been quietly outgassing in the outer solar system, another object has stolen the spotlight. Its official designation is C/2025 N1, but it's better known as 3I Atlas, the third confirmed interstellar object to pass through our solar system. Unlike BB, which is bound to the sun and will eventually swing back outward only to return in a few million years, 3I Atlas is just passing through. It came from somewhere else, some other star system, and it's on its way out, never to return. The discovery of 3I Atlas was a big deal. After Oumuamua in 2017 and 2I/Borisov in 2019, astronomers had been eagerly watching for the next interstellar visitor. When 3I Atlas showed up in early 2025, telescopes around the world immediately trained on it. And what they found was baffling. Let's start with the chemistry. The James Webb Space Telescope, JWST, obtained infrared spectra of 3I Atlas and found something extraordinary. A coma dominated by carbon dioxide, not water vapor, which is the primary volatile in most comets, not carbon monoxide, which is common in some, carbon dioxide. The CO2 to H2O mixing ratio was measured at about 8:1, meaning for every molecule of water vapor, there were 8 molecules of carbon dioxide. That makes 3I Atlas one of the most CO2-rich comets ever observed. Why does this matter? Because the relative abundances of volatiles in a comet tell us about where and how it formed. In our solar system, most comets formed in the region between Jupiter and Neptune, where water ice was abundant. But 3I Atlas likely formed around a different star, possibly a star with lower metallicity, fewer heavy elements, which would favor the formation of carbon-rich ices over water ice. In other words, 3I Atlas is giving us a glimpse into the chemistry of another planetary system, a system very different from our own. Then there's the polarimetry. When light scatters off dust particles, it becomes polarized, and the degree and direction of polarization depend on the size, shape, and composition of the particles. Observers measured the polarization of sunlight reflected off 3I Atlas and found something unusual, a negative polarization branch, meaning the polarization decreased at certain angles instead of increasing as expected. This signature is rare. It's typically seen in objects with very dark, carbon-rich surfaces, like trans-Neptunian objects or centaurs, but not in typical comets. It suggests that 3I Atlas might have a surface composition more similar to distant primitive solar system bodies than to the bright, icy comets we're used to. Finally, radio observations detected hydroxyl, OH, radicals in the coma of 3I Atlas. Hydroxyl comes from the breakdown of water molecules by ultraviolet sunlight. Its presence confirms that 3I Atlas is active, that it's outgassing, that it's not just an inert rock tumbling through space, and that, in turn, helps confirm that it's a natural object, not some kind of artificial probe, a question that came up with Oumuamua. So here we have two objects, BB and 3I Atlas, both active, both unusual, both capturing scientific attention in 2025. But they're very different. BB is enormous, 140 kilometers across. 3I Atlas is small, roughly 11 kilometers in diameter. BB is bound to the Sun on an elliptical orbit that will take millions of years to complete. 3I Atlas is on a hyperbolic trajectory, moving at high velocity, already on its way out of the solar system. BB likely formed in our solar system's Oort cloud. 3I Atlas formed around a different star, possibly light years away, and was ejected into interstellar space by gravitational interactions before drifting through the void until it happened to pass through our neighborhood. Yet despite these differences, there's something compelling about considering them together. Both are primitive bodies, relics from the early days of planetary formation, either in our system or another. Both are revealing chemistries that challenge our assumptions. Both are active at unexpected distances or in unexpected ways. And both are here, now, in our skies, at the same time. Is that meaningful? From a purely statistical standpoint, probably not. The discovery of interstellar objects has increased simply because our survey telescopes have gotten better. We're finding more asteroids, more comets, more of everything, because we're looking harder and more systematically. The fact that 3I Atlas showed up while BB is approaching perihelion is likely just timing, just chance. The universe is big, and things happen. But let's play with the idea for a moment. What if there is a connection? Not a direct causal connection, but an environmental one. What if both objects are responding to conditions in the heliosphere that are, right now, conducive to cometary activity? What if the solar wind is stronger, or the magnetic field is more turbulent, or the cosmic ray flux is higher? And that's triggering outgassing in objects that would otherwise remain dormant. There's some precedent for this kind of thinking. The solar system doesn't exist in isolation. It's moving through the galaxy at roughly 220 kilometers per second, and as it moves, it encounters different regions of interstellar space. The density of the interstellar medium, the strength of the interstellar magnetic field, the flux of cosmic rays, all of these vary depending on where we are in the galaxy. And all of these can, in principle, affect the heliosphere and the objects within it. Some researchers have proposed that the solar system periodically passes through denser regions of the interstellar medium, and that these passages could trigger increased cometary activity. The idea is that a denser medium compresses the heliosphere, changing the pressure balance at its boundary, and this change propagates inward, affecting the solar wind, the magnetic field, and ultimately the comets themselves. It's a speculative idea, and the evidence for it is circumstantial at best. But it's not crazy. It's based on real physics, even if the details are murky. If something like that were happening now, if the heliosphere were undergoing some subtle shift, you might expect to see exactly what we're seeing. Increased activity in distant comets like BB, and an uptick in the discovery rate of interstellar objects like 3I Atlas, which might be more detectable when the heliosphere is disturbed because they interact with the solar wind more strongly. Or maybe it's simpler than that. Maybe we're just in a period of good luck, astronomically speaking. We built JWST, we upgraded our ground-based telescopes, we launched survey missions, and now we're reaping the rewards in the form of discoveries. BB was always going to wake up as it approached the Sun. 3I Atlas was always going to pass through. We just happened to be watching at the right time with the right tools. Either way, the comparison between BB and 3I Atlas is instructive. They represent two ends of a spectrum. BB is the insider, the homegrown giant, the relic from our own solar system's past. 3I Atlas is the outsider, the traveler, the messenger from another world. Together, they bracket the diversity of icy bodies in the universe. And together, they remind us that the solar system is not a closed box. Material flows in from interstellar space. Material flows out. We're part of a larger galactic ecosystem, and events here are connected, however tenuously, to events everywhere else. This brings us to the final piece of the puzzle. Because BB and 3i Atlas aren't the only unusual things happening in 2025. The cosmos has been busy. Really busy. And if we want to understand whether BB's awakening is an isolated event or part of a broader pattern, we need to look at the other cosmic shocks that have made headlines recently. Flares, discoveries, revelations, all pointing to a universe that's far more dynamic than we sometimes give it credit for. Let's zoom out one more time. Let's take a step back from comets and orbits and look at the bigger picture, the cosmic events of 2025 that have astronomers both excited and slightly unnerved. Because if you've been paying attention to science news this year, you've probably noticed a theme. The universe keeps surprising us. And not in small ways, in big, headline-grabbing, paradigm-challenging ways. Start with the black hole superflare. In November of 2025, astronomers using X-ray telescopes detected a flare from a supermassive black hole at the center of a distant galaxy. This wasn't just any flare. It was one of the brightest ever recorded, equivalent to roughly 10 trillion suns in luminosity. For a brief period, that single black hole outshone its entire host galaxy by orders of magnitude. The flare was caused by a tidal disruption event, where a star wandered too close to the black hole and was torn apart by gravitational forces. The shredded stellar material then fell into the black hole, releasing enormous amounts of energy in the process. Now, tidal disruption events happen. We've seen them before, but this one was exceptional in its brightness and duration. It's forcing astronomers to reconsider models of black hole accretion, of how matter falls into black holes, and how much energy can be released. And it's a reminder that even at the largest scales, at the centers of galaxies millions of light years away, the universe is violent, dynamic, capable of sudden, dramatic change. Closer to home, the James Webb Space Telescope may have discovered a new moon orbiting Uranus. Designated S/2025 U1, this tiny world is only about 10 kilometers across, roughly the size of 3i Atlas, actually. It's faint, hard to see, and might not even be confirmed for months or years as astronomers refine its orbit. But if real, it raises a question. How did we miss it for so long? Uranus has been studied for centuries. Voyager 2 flew past in 1986. Ground-based telescopes have observed it for decades. And yet, here's a moon, a whole world, that we somehow overlooked. The answer, probably, is that space is bigger and darker than we like to admit. Even in our own solar system, even around planets we think we know well, there are hiding places. Small, dark objects can evade detection for a very long time. And that has implications. If we're still finding 10-kilometer moons around Uranus, what else are we missing? How many other objects in the outer solar system or beyond remain undiscovered simply because they're faint, or dark, or in the wrong place at the wrong time? Then there's the Euclid Space Telescope, the European Space Agency's mission to map the distribution of dark matter and dark energy across the universe. In 2025, Euclid released its first major data products: detailed maps of millions of galaxies, measurements of gravitational lensing, and constraints on cosmological parameters. The results are both confirming and challenging. They confirm the basic lambda CDM model of cosmology, the idea that the universe is made mostly of dark energy and dark matter, with regular matter being just a small fraction. But they also hint at tensions, small discrepancies between different measurements that might indicate something's not quite right with our understanding. These tensions have been simmering for years. The Hubble constant, the rate at which the universe is expanding, seems to have different values depending on how you measure it. The clumpiness of matter in the universe, quantified by a parameter called sigma 8, also shows discrepancies. Euclid's data is adding fuel to these debates, suggesting that either our measurements are systematically off, which is possible, or there's new physics at play, which would be revolutionary. Why does this matter for BB? Because it speaks to a larger theme. The universe is not static, not fully understood, not predictable in all its details. We like to think we've got the big picture figured out. We know how stars form, how galaxies evolve, how planets orbit, but the details, the edges, the outliers, those are where the surprises hide. and 2025 has been a year of surprises. There's also the ongoing weirdness with solar activity. The sun is approaching solar maximum, the peak of its 11-year cycle, and it's been more active than predicted. More sunspots, more flares, more coronal mass ejections. Some of this is just normal variability. Solar cycles are never exactly alike, but there's a nagging sense among some solar physicists that this cycle feels different, stronger, more erratic. Whether that's real or just observational bias is hard to say. The sun doesn't come with a manual. We're still learning how it works. Put it all together, and you get a picture of a cosmos in flux. Black holes flaring to record brightness. Hidden moons revealing themselves. Dark energy measurements showing cracks in our theories. The sun acting up. Interstellar objects arriving with strange chemistry. And a giant ancient worldlet waking up in the outer solar system. Any one of these events, taken alone, is interesting, but not alarming. It's science happening, the universe doing its thing, researchers updating their models. But taken together, they form a pattern, or at least the suggestion of a pattern. A sense that something is shifting, that the cosmic background we take for granted is becoming a little less stable, a little more surprising. Does this mean we're entering a new cosmic era? Some kind of energetic transition that's affecting everything from comets to galaxies? Probably not. The universe is always surprising. Us, because the universe is vast, and we're still learning. Every new telescope, every new mission reveals things we didn't know. That's how science works. We don't know everything, so we keep looking, and we keep finding. But there's also a part of me, and maybe a part of you, that wonders, what if there is something to this? What if the solar system is entering a region of space that's more energetically active? What if the galaxy is going through a phase that increases cosmic ray flux, or interstellar object encounters, or cometary perturbations? What if BB's awakening is not just about BB, but about the environment it's moving through? Here's the thing about cosmic change. It happens on timescales we don't intuitively grasp. The solar system takes 230 million years to orbit the galactic center. The sun's position in the galaxy shifts, slowly, moving through different spiral arms, different densities of interstellar medium, different magnetic field strengths. On human timescales, these changes are invisible. But on astronomical timescales, they're significant, and they have consequences. For example, there's a hypothesis that the solar system periodically passes through the galactic plane, the densest part of the Milky Way's disk, and that these passages correlate with mass extinctions on Earth. The idea is that passing through the plane increases the flux of comets from the Oort cloud, which increases the rate of impacts, which occasionally triggers catastrophic events. The evidence for this is debated, and the timescales don't always line up, but the basic mechanism is plausible. Galactic environment affects solar system dynamics, affects life on Earth. We might be living through one of those transitions right now. Not on a catastrophic scale, not in a way that threatens civilization, but in a subtle way. A way that increases the number of interesting objects we see, the frequency of unusual events, the sense that the cosmos is waking up. And if that's true, if we really are in a more active phase, then BB is not an anomaly. It's a herald, the first visible sign of something larger. Or maybe I'm overthinking this. Maybe BB is just a big comet doing what big comets do. Maybe 3I Atlas is just a random interstellar traveler. Maybe the black hole flare, the Uranus moon, the Euclid tensions, the solar activity. All of it is just coincidence, the normal background hum of a dynamic universe. Maybe we're pattern-seeking creatures looking for meaning in noise. But here's what we know for certain. BB is real. It's out there, right now, 16 astronomical units from the sun and closing. It's outgassing. It's active. It's massive. And it's coming from a direction we don't usually watch, on an orbit we don't usually see, at a time when other strange things are happening. Whether that's meaningful or not, we'll find out. Perihelion is 2031. The ecliptic crossing is 2033. We have less than a decade to watch, to measure, to understand, and maybe, just maybe, to send a mission. Because if BB really is a primordial time capsule, if it really does hold ices and organics from the birth of the solar system, then studying it up close could answer questions we've been asking for centuries. Where did we come from? How did the solar system form? What materials were present at the beginning? Are we alone? Those are big questions. Questions worth chasing. Questions worth risking a spacecraft for. And if BB does something unexpected along the way, if it fragments or outbursts or changes trajectory, well, that's just more data, more information, more pieces of the puzzle. So as we close, I'll leave you with this. Look up. Not figuratively, literally. Go outside on a clear night and look up at the stars. Somewhere out there, beyond Saturn, beyond the reach of most telescopes, a giant worldlet is falling toward the sun. It's been falling for thousands of years, and it will keep falling for thousands more. You can't see it with your eyes. You probably never will. But it's there, and it's changing. And whether that change is ordinary or extraordinary, whether it's physics or prophecy, we're about to find out. The solar system is not done surprising us. BB is proof of that. And whatever comes next, whether it's a quiet perihelion passage or something far more dramatic, we'll be watching. Because that's what we do. We watch. We wonder. We wait. And when the universe finally reveals its secrets, we're ready to listen. The giant is awake. The clock is ticking. And the show is about to begin.